Alright, in this video we are going to be doing more on limit strategies whenever we get a limit of 0 over 0. We'll also talk about piecewise functions, and then we'll talk about trig limits. So here, if I were to use direct substitution, I'm going to get 0 over 0. So once again, go ahead and write your little statement so that this is an indeterminate form of 0 over 0. Now, recall back in Math 3 and maybe in pre-calc where we have to rationalize radicals. We're not really rationalizing, but we're doing something very similar. Well, it's not really rationalizing, but it's multiplying by the conjugate. So here I'm going to multiply by the conjugate. The square root of 2 plus x plus square root of 2 over the square root of 2 plus x plus root 2. Now, the reason why I'm multiplying by the conjugate is because I want to get rid of the radical. And the reason why is because I don't want 0 over 0. Now, why did I multiply by the conjugate? Well, if I multiply this out, I'm going to get the limit as x approaches 0 of 2 plus x minus 2 whenever I multiply this out. Then I have x over the square root of 2 plus x plus root 2. Even though I have a radical at the bottom, that's okay, because you'll see that the 2 minus 2 will cancel out because that's going to be 0. And then the x over x will cancel out. So now I'm just left with the limit as x approaches 0 of 1 over the square root of 2 plus x plus root 2. And then if I were to use my direct substitution, I'm going to get 1 over root 2 plus root 2, or 1 over 2 root 2. Now, on the AP exam, you do not need to simplify your answer. So here, even though we've asked you to probably rationalize this in Math 3 and pre-calc, you don't have to do that here. So you could just leave your answer just like that, and they will be happy. I will be happy. Now, the only time where you probably might need to rationalize this is on an MCQ, where you probably don't get an answer like this, but an equivalent one on multiple choice. So here I have the limit as delta x approaches 0 of x plus delta x squared minus x squared over delta x. So here, once again, I'm going to go ahead and do my little statement, because if I were to plug in delta x here, that's going to be 0. X squared minus x squared is going to give me 0. And then, of course, my denominator is going to be 0. So this is an indeterminate form of 0 over 0. So now we got to think about a strategy in terms of how can I simplify this? Well, I have a square right here. So one strategy that I might think of is expanding my x plus delta x squared to be x squared plus 2x delta x plus delta x squared minus x squared all over delta x. You'll notice that the x squares will cancel out here. So that's going to cancel out, which means I'm left with the limit as delta x approaches 0 of 2x delta x plus delta x squared over delta x. I could probably factor out a delta x. So now I have the limit as delta x approaches 0 of delta x, 2x plus delta x over delta x. That cancels out. So now I have the limit as delta x approaches 0 of 2x plus delta x. And then if I were to use direct substitution for delta x approaching 0, I'm just left with 2x as my answer. So that's just me expanding for this one right here. Looking at my third one, once again, a surprise, surprise. Can't really use direct substitution, so I gotta think about a way for me to simplify this. Notice how I kind of have a complex fraction right here. So what I want to do is probably make this into one fraction and see if I can manipulate the numerator. So what I'm going to do here is think about my LCD. So I'm going to have 3 right there. And then I'm going to have 3 plus x right here. So that's going to give me the limit as x approaches 0 of 3 minus 3 plus x over 3 plus x. I'm going to simplify that a little bit so that it gives me a negative x right here. And then over x. I'm going to same change flip this so that I have the limit as x approaches 0 of negative x over 3 plus x times 1 over x. Notice that the x's will cancel out now, so now I'm just left with the limit as x approaches 0 of negative 1 over 3 plus x. I know I don't have a lot of space, but now I can do direct substitution. That's going to give me negative 1/9. So here I made it into one fraction and then call it a day. So most of these functions were irregular functions. They weren't piecewise functions. Now here, I gotta change that to be a -2. Oops. Now here, we have a piecewise function. So what I want to do here is verify that the limit as x approaches -2 from the left equals the limit as x approaches -2 from the right, which is eventually going to equal x approaches -2. So this must be true, the left side must be true, and equal with the right side for the whole limit to be true. So here I'm going to look at x approaching -2 from the left, and if I were to look at my piecewise function, -2 from the left is going to be my top part right here. So I'm going to have x cubed plus 2x squared. I'm going to plug in -2 and see what that gives me. So that's going to be -8 plus 2 times -4. Nope, sorry. 2 times 4. That's going to give me 0. So that's my first part. Now my second part is looking at my right side limit. So my limit as x approaches -2 from the right. This needs to be 0. If it's not, then the limit as x approaches -2 does not exist. So I'm going to plug in -2. 2 times -2 is -4. I'm going to get e to the 0, which is 1. So notice how I have a limit of 0 and a limit of 1. Because they are not the same, this tells me that the limit as x approaches -2 of f of x does not exist. So we did that algebraically. What we're going to do with number 4 here at the bottom is graph the piecewise function and then look at it graphically in addition to it algebraically. So first, what we're going to do is go ahead and graph our piecewise function right here. So here I have 2 minus x if x is less than -1. I'm going to plug in -1, and that's going to give me 3. That's going to be an open circle at 3. And I have a negative slope of -1. So here's my first subfunction right here. My second subfunction is from -1 to 1, and that's for x. So that's this right here. And then I have x minus 1 squared if x is greater than or equal to 1. So that's going to be 2. If I plug in 2, that's going to be here. If I plug in 3, that's going to be 4. And then this is the quadratic. So it's going to look something like that. Okay, so now I'm going to go ahead and look at the limit as x approaches 1 from the left. So if I were to do 1 from the left right here, that's going to be 1. If I approach it from 1 from the right, that's going to be here, which is going to be 0. And notice how they don't match up, and since they don't match up, my limit as x approaches 1 does not exist. Likewise, if I approach negative 1 from the left, well, if I do negative 1 from the left, I'm going to get 3. And then if I do negative 1 from the right, I'm going to get negative 1. Notice how they don't match up, and since they don't match up, I know that my limit does not exist. All right, in the next video, we'll talk about trig limits, and then the squeeze theorem, and then limit laws.